Now, before I get into this next problem, because so far u substitution is seeming pretty easy, but there's something to remember, which is that with u substitution, actually technically with any substitution, the integral must be either all x or all u. But you can't mix and match. There's no mixing of variables allowed, at least until you're in Calc 3, and then there's a whole other problem, right? But in Calc 1 and Calc 2, there's no mixing. So I have x, x, and x. This is currently an x integral, but I'm going to need to switch it into a u integral. So let's just keep this all in mind for a second from now. All right, so we can see, hopefully, that we have an obvious candidate for u. U is 4x minus 3. Pretty obvious, no problem. It's nested inside another one. Lovely. The derivative of that would be 4 dx. Okay, well, I don't want the 4. I don't have an extra 4 in this problem. But I do want the dx part, no problem. So I'm going to say 1/4 du is equal to dx. Lovely. Problem. Because I haven't covered x. I don't have anything for it. So if I try to write my integral right now, so if I try to write this as an integral, I can do the square root of u. That's no problem. I can say 1/4 du. Sure. But I'm not allowed to write x here. That's actually wrong. Like, I cannot write the x. That's no good to me. I have to write something else. I have to write something with u. So that's why I'm saying it's a subtle variation, because I need some way to write x in u form. If only I had, I don't know, some function of x and u that relates them. Huh? See, if u is 4x minus 3, couldn't I solve this for x? So that would mean that u plus 3 is equal to 4x. That would mean u plus 3 divided by 4 is equal to x. And that's what I would put in here. Because you are never allowed to write both x and u in the same problem. Not in Calc 2, you're not. You either write u or you write x, right? All u's or all x's. No mixing and matching. Right? Never allowed to have two different variables in there. Not in Calc 2. In Calc 3, yes, you can, but there's something else going on in Calc 3. Okay, so I need to do this. Let's think. All right, so I've got a 4 and a 4, and they're both in the denominator. So that's really 1/16. I'm just going to put that out in front and get it out of the way. And then I have a u plus 3 right here times a u to the 1/2 power du. Okay, well, I still have to take the integral of this. I have a product. We don't have an integral rule for product. We have a derivative rule for product, but not an integral rule. So I'm going to have to use algebra, right? Just like we had to do a couple pages ago. Distributing, right? Remember? Distributing, foiling, that could be one of the rules that we have to, or techniques that we have to use if we don't have u substitution available to us. So we are going to distribute, right? It's not technically FOIL because it's not binomials. So I'm going to rewrite this as 1/16 integral. U to the 1 times u to the half would be u to the 3/2 plus 3 times u to the 1/2 du. Just a little recall for your own benefit, because it's been a while since you've been in math class. A to the p times a to the q is a to the p plus q. That's where this u to the 3/2 is coming from, right? U to the 1 times u to the half is u to the 1/2. 1/2 is 3/2. Okay, well, I can take the integral of these things, no problem, because these are just powers. Powers are easy. So this is 1/16 out in front. The integral of u to the 3/2 is u to the 5/2 times its reciprocal, which is 2/5, plus 3, because that 3 hasn't gone anywhere, and then u to the 3/2 times its reciprocal, which is 2/3, plus c. Technically, the constant integration, you can think of it as inside the bracket or outside of the bracket. It doesn't really matter because it's just an arbitrary constant anyway. So makes no difference. All right, so this is, let's think here. 2 goes into 16 8 times. 8 times 5 is 40. So this is 1 over 40 u to the 5 halves plus, well, the 3's are going to cancel because 3 divided by 3 goes away. So that leaves me 2 over 16, which is 1/8, because 2 goes into 16 8 times. So 1/8 u to the 3 halves plus c. And this would be 1 over 40 plus 1 over 8. And then u was 4x minus 3. And then we're done. So the important part for this problem is to remember you're never allowed to mix, right? All x's are all u's, and that's why we have to do this piece right here, right? Because we have to take care of this x. All right, now one other one, which might not seem to be related, but it is related, and this one involves an arc-trig function. So let me go back to the tables of basic integrals. So these are the basic integral sheets. And you'll notice that the one that we're looking at looks a lot like one of these. So our particular problem has 81 minus 121x squared, which looks a lot like this formula right here, number 18. Now, this is going to come in handy for us later in chapter 8 as well, but we want to be able to use these basic rules even now, because you're not expected necessarily to memorize the arc ones especially. I mean, I expect you to know the derivative sign is negative cosine, but this particular one we might not know off the top of our heads. All right, so let me rewrite the rule. So rule number 18, I'm going to write it on my page and then I'll show it to you in a second, says that if I have du over the square root of a squared minus u squared, that is equal to the arc sine of u over a plus c. Okay, so this is rule number 18. Now, how does this help us? Well, we have to look at our problem and kind of figure out how it relates. So if it's a squared, and now remember in these tables, a is always considered to be a constant, and u is always considered to be some function of your variable, right? So a, b, and n are and c are constants. So therefore, a has to be a constant. A squared has to be 81. So that means a is 9, right? Because 9 squared is 81. And then u squared, right? So if I did a squared here, u squared is 121x squared. So u would be the square root of 121x squared, which would be 11x. All right. Now there's just one other problem, which is the problem itself has a du sitting in it, right? See how you need to know u-substitution? All right, so du is the derivative of u, right, with respect to x. So that'd be 11 dx, right? But I don't have an 11 dx. I mean, look at the problem. There's no extra 11 sitting in here. There's only a dx. So I need 1 over 11 du is equal to dx. And then I'm basically going to substitute into the formula, right? So I've got the pieces that I need. So I am taking the integral of, so using rule number 18, I'm taking the integral 1 over 11 integral du. Now, if you want, you could put the 1 over 11 here, but it's just going to pull it out in front in a second anyway, so it doesn't really matter. Over the square root of, and then it was 9 squared minus 11x squared. And according to our rule, according to our formula, that's going to be 1 over 11 arc sine. Oh, arc sine, by the way, is the same thing as this. Inverse sine. So if some instructor wrote them with the negative powers, I tend to write the word arc because the negative powers gets people confused, but either one. And then I'm going to write u, which was 11x, divided by a, which was 9, plus c. And I'm done. The only tricky part about this, the only thing that was different straight up than the formula, was that I had to have this part right here. This is key, right? That it's 1 over 11, right? That 1 over 11th du, right? If you want to think of it this way, right? There's a 1 over 11 right here, but then that pulls it out and puts it right there. That's the only thing that makes this problem remotely difficult.